Hey everyone. So my talk's going to be about adding observability to Nomad application, and we're going to do that with Grafana, and we're going to apply that to Nomad application. So before we start, I just want to tell a little story about microservices. And not long ago, there was some sort of a shift. We were using monolithic for simplicity. I'm not sure how old you are, but it wasn't that long ago. And with the explosion of internet and services, we needed to shift to microservices. And this was all for a good reason, right? It could be organizational reason. Maybe in your organization, a small team was in charge of a part of the application, and it was easier to cut that down into a single application. And so they were in charge of that, and they would exchange via contract to another team. Could be just scalability. It's much easier to scale when the application is a bit smaller, but also reliability. And suddenly, it all escalated very quickly. The rise of workload orchestration, such as Nomad and Kubernetes, made this change even much more easier. And this is a slide showing an example of Amazon. Back in 2001, they were running a big monolithic architecture. And then 7 years later, everything just exploded and they ran what they called the Death Star. So that's on Twitter from Werner Vogels from Amazon. So we solve a problem, but it came with a price. And I don't think it's for nothing if the SRE role has suddenly became more popular in the industry. And we often talk about the greatness of microservices, but we forgot about one big disadvantage, which is the operational complexity that comes with it. And this is a quote from Martin Flower, which is the father of microservices, if we can say. And he's basically saying that you need a mature operation team to manage a lot of services which you are deploying and redeploying regularly. And I think I'm going to add to that you also need a solid observability story. So hello again, everyone. I'm Cyril. I'm from France. I work at Grafana Labs on the Loki project. And this talk is going to be in 3 parts. The first part, we're just going to set grounds on what is observability. And then the second part, we're just going to see what's the Grafana idea of observability. And then the last part is going to be on Nomad. So we're going to apply that directly to Nomad. So let's get started with what is observability. So the definition is pretty simple. Also, it's a nice buzzword, observability, but the idea is you should be able to measure the internal of your system by looking at external output. And in practice, it means that you want to make sense of your complex distributed system. And so what are those external outputs? So there's 3 of them. The first one being, so there's no specific order, but the first one being metrics. Metrics are numerical representation that are measured over a specific interval of time. And they're pretty cheap to store because it's just, float values. And they could be CPU time, error rate, network throughput, total number of order, whatever your team wants to measure. The second one is logs. Logs are immutable timestamp event records. I think it's the go-to from a lot of developers. You usually use log even in your test all around your application to try to understand what's happening in your application. They're basically the insurance policy. And they are usually more details than metrics. And I'm a log first person. I guess it's because I'm working on Loki. And And I think logs are really are the best. And the last one, traces. Traces are a bit less popular, and I think it's because the instrumentation it's a bit more difficult. But I don't, over time, I think it's gonna be way much easier with projects such as OpenTelemetry. So traces are a series of events that span across multiple services in your infrastructure, and they represent the life cycle of your request. And they usually help you to pinpoint which part of your system is introducing latency. All right. So today's reality, disparate system, disparate data. I'm pretty sure a lot of people out there can relate to this. I used to work at Ubisoft, gaming company, and we were using Prometheus, Splunk, Elastic, Grafana, Influx, Zabbix, all of them. And each team at Ubisoft were really able to choose what worked for them. They were able to choose their own stack. And I don't think it's a problem in itself. I think it's actually a good thing that every team are able to choose. However, I believe this makes the incident response a bit more trickier than it should be, right? You need to context switch between multiple tabs when you want to move from a metrics or logs. You also need to craft queries from, let's say, Prometheus query to a Lucene query for Elasticsearch. And we're human, we can make mistake. And so that makes, the incident response workflow a bit stressful. So the second part, the Grafana stack. So we talk about the reality of observability and all the different systems that you can use. And Grafana is really here to just try to solve this problem. Grafana tries to be at the center of your observability story, and it tries to bring all the data all together, whatever the data source you're using. And we also believe that you should be able to choose your own fate, like the tool that works for you. However, that doesn't mean that we are not opinionated and that we don't have what we think is the best combination. And the best combination we think is Prometheus, Loki, and Tempo. All of them are open source projects, so feel free to try them out. And it wouldn't be fair to say that this is what we think is the best combination without explaining why. So I'm just gonna quickly give a quick introduction to each of those projects. So let's start with Prometheus. Prometheus is a monitoring system. It has been really widely adopted now, and mainly because I think it has been built from the beginning for the cloud, and this is because of its service discovery. So that means that either if you're running it on a cluster that has a console, or whether it's Kubernetes, you should be able to discover all the application running, and it will automatically attach metadata. And it has a powerful query language, which is multidimensional and very rich for ad hoc analysis. You can write actually nice SLO alerts with Prometheus. There's a nice talk from one of the Prometheus maintainer, Matthias, which go through this, and I think it's very nice. All of this is, again, open source, and the idea of Prometheus, the trade-off is that it's incredibly resource efficient and very simple to operate. It's just a single binary that you can run in your cluster. Prometheus also uses a pull model instead of a push model, so it connects to your application to gather the metrics. So Loki, the project I'm working on, Loki is a multi-tenant log aggregation, heavily inspired by Prometheus. So that means that the language itself to query Loki is very much similar than the language that we can use in Prometheus. And the idea is that if you already know about Prometheus, then you should be ready to go with Loki. You should be quickly efficient in writing queries and finding the logs that you're looking for. What's nice also is that it shares the same label discovery than Prometheus. And so you can attach the same metadata from your metrics to your logs, which makes it super simple to switch between metrics and logs. And we'll see that in the last part. It does take a different approach to storing the data. We only index metadata, and the rest is just highly compressed log. And so that's what makes it super easy and affordable to operate. Just to give you an idea, for 10 terabytes of logs, 300,000 jobs or pods, the index usually is 200 megabytes, which is like 15,000 less time than what it would be with a system that indexes the whole log itself. Again, this is open source, and it supports a lot of different cloud backend, depending on where you want to store the data. I think the idea of Loki is really we shouldn't ask the developer to make any compromise on their log. I've heard too much, let's log less because it stressed too much the log ingestion pipeline. But I think the logs are really, insurance policy for developers, so we shouldn't ask them to log less. And the last one, the new one, is Tempo. So Tempo is a it's a easy to use iScale distributed tracing backend. So it basically just collect span and traces. And it's cost efficient because it takes an interesting trade-off where you only index trace ID. So you can only search in Tempo via trace ID. And that's what makes it super easy to scale. What's nice about this is you can also sample all the traces. You don't need to just sample a subset of the traces, which can be very irritating when you are trying to narrow down a problem and then you realize that one trace is just partial. You don't have all the information. So how the trace discovery is working? Well, the idea is we defer that to other backend like Loki. So usually in your logs, you should be having the trace ID, and you can easily find the logs that is saying something is going wrong. And then from that logs that has the trace ID, then you can jump to Tempo and find the trace. Soon, Prometheus will also add exemplar, which will allow you to switch from metrics to traces. Again, Tempo is open source and it supports all different type of clients. So whether you're instrumented with Jaeger, Zipkin, or OpenTelemetry, all of this will be working. So all of those technology are deeply integrated, and that lead us to a better incident workflow. There's no more context switches. There's less chance to make a mistake when you translate a query from one system to another. There's less thing to learn. At the end of the day, there's less stress when there's a stressful situation and you need to find the problem of an incident. All right, let's try to see how we can apply that to Nomad. Everything that I've prepared for this demo is going to be available on my GitHub, so you can try this directly at home. So we're going to deploy an application that is named the New Stack. It's a simple feature application. So there's like a front end, a database, and a web app. All of this is instrumented with Jaeger, Prometheus, and Loki. And again, this project is available online if you need to look to try it out. Just a quick glimpse at what we are going to deploy in Nomad. So I'm using Vagrant here, so that makes it super simple for everyone. So Vagrant is also from HashiCorp. This makes it super simple for everyone to try it on their own. All you need is just the Vagrant CLI and you can get started. So we're going to deploy Grafana, Loki, Prometheus, Promtail. Promtail is actually the Loki agent that's going to tail the log file directly. And I'm just going to quickly show the configuration for that, just to show you how the service discovery configuration is exactly the same as Prometheus. We're also going to deploy Tempo, and TNS is the actual application that we want to observe. And we're going to add a little dashboard. All right. So let's go into the demo. So it's already running. I ran it before starting the talk. Just gonna quickly show you the configuration. So the Prometheus configuration, there's a scrape config where you actually define what services you want to scrape and how you want to attach metadata. It's a bit complex at first here, but we don't need to drill down too much into this. I just wanted to show you that I'm using console service discovery, which goes very nicely with Nomad. And if we look at Promtail, Promtail is actually using the exact same configuration. So that's one more advantage, is you don't need to learn another configuration system. Promtail and Prometheus use the same. All right, so let's look at what we have in Nomad. So in Nomad, we can see we have all those jobs running. So Grafana, Prometheus, Tempo, all of this is running nicely on my local machine. And we have also console. So as I was saying, it's all connected together. So console is showing all the service that he has discovered. And let's go to Grafana. All right, so that's the local Grafana. As you can see, I started this very early. And what we're going to do is let's imagine that I'm doing an incident response. And I wake up in the middle of the night. And I can see that there's an issue. I've been paged. You can see there's an issue here. And the first thing I want to do is I want to start drilling down, if I can, okay, using Explore. So I can go in Explore view. I can drill down on a specific time range, sorry. And I can, so you see the query here comes from the dashboard automatically. And you see when I switch to Loki, the query will automatically be translated for me. And I can see the logs of this application. Now, if I want to drill down, I could, for instance, look for errors, right? So I can find errors happening. So I can see it's a recurrent problem. It seems to be a database issue. I can write a complex query with Loki to generate directly metrics from the logs. So I'm just gonna see if I have a query story somewhere. Let's see if I have something interesting. So I could look at the rate. Yeah, I'm just gonna do a rate. So I'm gonna run this query. And I can see that the errors are happening quite often. Now, if I go back to the logs, I'm going to try to find a trace ID and jump directly to a trace to see what's happening to my system across multiple applications. So I know that there's a status log somewhere. I'm going to run that. I'm going to remove that query here, right? So I can see there's a status. I can see all the status. So all of these are just 200s. So I'm only interested into the 500s. So I can pass the logs and ask for a status that is higher than 499. And this time I'm only seeing errors. And you can see here the trace ID. This application is automatically printing the trace ID. And that's how I can drill down. So I can click on the log itself, and I can go on the trace ID directly. Oh, and that's not working. I'm going to try another one. This one. Yeah, it's not working. So usually you should be able to directly jump into a trace and be able to see the problem across multiple applications. On this specific instance, I have an issue with the space on the disk because it's running on a virtual machine. But all of this should be working with a distributed system. So that's pretty much it for demo. I'm going to go back to the slide. All right. Present. So what's next? So it's, monitoring and observability is not just about your application. It's also about all the tools and all the application that you are using. Nomad comes with a telemetry system that you can activate, and that gives you Prometheus metric automatically. You can also add exporters. So exporters are small applications that you deploy in your cluster and that will make available more metrics. So there's a Prometheus node exporter, which will scrape metrics from the node itself. And so you can get CPU of the node and the health of the node. There is a console exporter. All of this comes with nice dashboard too. Console exporter gives you information about the status of console. And then, whoops. And then if you are using journal D, which usually you are with Nomad, then you can activate that with Promptail. And so you can get logs from Nomad itself or anything like Docker, which is running on the node. CAdvisor is also nice to have if you're running with the Docker plugin on Nomad. That gives you information about each of those container, like CPU and memory usage. And because Nomad is really nice and powerful, and you can run Windows nodes, then you can also install Windows Exporter. And whatever application you're using, whatever database, there most likely exists an exporter for it. So you should be able to find what suits you. And that's pretty much it for the talk. Everything that I've shown here is available on my GitHub. And if you have any question, you can reach me on Twitter, by email, and I'm also available on Slack, on the public Slack of Grafana, and I'm usually on the Loki channel. Thank you, everyone.